Graphing translations of simple rational functions. To graph a rational function of the form y equals a over x minus h plus k, follow these steps. Draw asymptotes at x equals h. So we're going to look at the denominator because that's where h is located. And y equals k. So we're going to look at the constant in the back. Step 2 is going to be plot points to the left and to the right. So we're going to be using Desmos to find these points. And then we're going to connect the points and draw our branches. So let's take a look at an example here. So it says graph f of x is equal to negative 4 over x plus 2 minus 1. So we're going to look for our vertical asymptote, x equals. And again, we need to look at our denominator. So I'm going to take my highlighter, highlight x plus 2, and pretend there was parentheses here. Right? Remember, we cannot trust parentheses. It's always opposite. So our asymptote is at x equals negative 2. And then for our constant in the back, that's our k. Let me take my highlighter. And that one is truthful. It is going to be negative 1. So y is equal to negative 1. And we're going to draw dashed lines at negative 2 and at negative 1. So let's go ahead and do that. So y equals negative 1. Draw my dashes. And for x equals negative 2, you're going to draw some dashes as well. And now what I want to do is I want to graph this in Desmos and find some points that I can plot to the left and to the right. So let's go ahead and go over here. I already have it typed up in Desmos. I'm going to look at my values. So I don't want to look at the undefined. We already mentioned that x was equal to negative 2. So I'm going to look at the 3 points below and copy those down. So let's go ahead and do that. So we have negative 1, negative 5, 0, negative 3, and 1, negative 2.3. Let's graph that. Negative 1, negative 5, 0, negative 3, and 1, negative 2.3. We're going to connect. And again, we're going to get super close to that horizontal line. And remember that we need to get some points to the left. So we're going to go back to Desmos and notice that it stops at negative 2, but you can type in what you want to see. So we want to see what's going on at negative 3. Let's also see negative 4 and negative 5. And I'm going to go ahead and plot these points as well. So negative 3, 3, negative 4, 1, negative 5.3. So let's go back and plot those. Negative 3, 3. We have negative 4, 1. And we had negative 5.3. And we're going to go ahead and connect. And remember, it's going to get super close to those asymptotes. So let's go ahead and mention the domain and range, since we've already written down the asymptotes. So for domain, it is all real numbers x such that x cannot equal, and now you have to look at your asymptote. So we're so used to putting 0, but now it's negative 2. So watch out for that. Same thing for range, you need to watch out. So it's going to be all real numbers y such that y cannot equal. Look at your asymptote, negative 1. Now you're done.